topic is friction. First thing, first things first. Friction is a contact force. Friction is a contact force. Now, contact force actually has got two components. There is what is called normal contact force. If you look at this word normal contact force, if you look at this, the word normal, this implies perpendicular. So normal contact force, it is also a contact force, but it is perpendicular to contact surface. So if I have a floor like this and I put a block of mass m, so we know that this is the contact surface. What I am showing in the copper color, that's the contact surface. Perpendicular to contact surface means in this direction, that will be the normal contact force on the block. It is perpendicular to contact surface. Whereas friction is a tangential component of contact force. Friction, on other hand, is tangential component of contact force. So actually friction and normal together is called contact force normally. So if the problem says find the contact force, suppose if there is a floor, if there is a block, if there is, let us say, normal force acting on it, and let's say there is also friction acting on it for some reason, then if somebody says find the contact force, what you should do is you should find resultant of friction and normal. That will be the net contact force. I'm using some parallelogram law or triangle law to add these forces. So if the problem says find the contact force, students make this mistake. They find the normal contact force and say that is the answer. Wrong. Contact force by definition means the total contact force. So contact force by definition is total contact force. Okay, it is the resultant of normal contact force and frictional contact force. It is the resultant. So the total contact force has two components. One perpendicular to surface is called normal, and along the surface is called friction. So total contact force has two components. One perpendicular to contact surface called normal contact force. So this component of contact force is called normal contact force. So it's only one component of the total contact force, one part, you can say, just one part. The second, the other component parallel to contact surface, this is called friction, tangential component of contact force. So I would define friction like this. Definition of friction. Now I am coming to the definition. When does friction come into picture also? I'll tell you in a minute. So definition of friction is tangential component of contact force. Friction is tangential component of contact force acting between two surfaces in contact, acting between two surfaces in contact when there is relative motion between surfaces, when there is relative motion between the two surfaces, or there is a tendency of relative motion. There is a tendency of relative motion between the two surfaces. Very complicated looking definition of friction, but it has all the ideas in it. So let me explain this. Friction is tangential component of contact force. There is another component which is normal component, which we simply call as normal force. So specifically friction is that component of contact force which is parallel to the surface. And when does it come into picture? It is acting between two surfaces in contact. So the surfaces, both the surfaces must be in contact for there to be friction. For example, here in this case, the lower surface of the block and the ground are in contact. Okay, and hence I am able to draw friction. So there must be two surfaces in contact, and these two surfaces, either they are in relative motion. That means with respect to one surface, other is moving. Either they are in relative motion, then friction acts, or there is a tendency of relative motion. Means there is no relative motion, but they are trying to move separately. Somebody is trying to move both the surfaces separately. There is a tendency. Then also friction can act. Suppose there is a heavy suitcase on the floor. You are pulling it. So with respect to floor, suitcase is moving. So there is a friction on it. In another case, there is a heavy suitcase on the floor. You are pushing it, but it's unable to move. Then also there is friction. So there is no relative motion there. Suitcase is at rest on the ground, but there is a tendency to move separately because you are pushing it, and friction is opposing that. So even when there is a tendency of relative motion, friction will oppose or resist that tendency. Then also friction can act. So friction is tangential component of contact surface acting between two surfaces in contact in one of the two cases. One, there is relative motion between the two surfaces, or there is a tendency of relative motion between two surfaces. This is the idea about friction. Now, if there is relative motion between the surfaces, so I would write here, if there is relative motion between surfaces, it's called kinetic friction. This is the simpler of the two. Friction has two aspects to it. One is what is called static friction, other is kinetic friction. And among the two, kinetic friction is simpler and easier to deal with. Static friction is very dangerous. Very tricky problems are there. So if the two surfaces which are in contact have relative motion between them, what is meant by relative motion? If you stand on one of these surfaces, the other is moving with respect to you. Then the friction that acts between two such surfaces is called kinetic friction. So friction is of two types. One is static friction, one is kinetic friction. Suppose you put both your palms in contact and then you try to move, but you're not moving. So there is no relative motion. There is static friction between your palms. On the other hand, so you sometimes do like this. Now, with respect to one palm, other is moving. So the type of friction that acts in such a case will be kinetic friction. Kinetic friction is the easier to deal with. It is the simpler of the two. Okay, it is the simpler of the two. Now, let us first see what is the direction of kinetic friction when there is relative motion between two surfaces. In which direction will it act? First, we will see the direction. Then I will talk about the magnitude of the kinetic friction, how to calculate its value. So suppose I have two planks. This will be a best example. Let me draw it properly. Suppose there is one plank, okay, and there is another plank, okay, something like this. They are, let's say, on the floor. So this is, I call it A and I call it B. Suppose A is moving with, okay, before that, let me copy this figure. I need this in multiple cases. So let me copy this. Okay. Suppose A is moving with 3 meter per second velocity. So this upper block or upper surface is moving, and lower is moving with, let us say, 4 meter per second velocity. So you see now the two surfaces of A and B which are in contact, they are not relatively at rest. There is a relative motion between them. They are moving separately with different velocities. So the friction between A and B will be kinetic, first point. So friction between A and B is kinetic. On the other hand, had I said A also had 4 meter per second velocity and B also had 4 meter per second, then it's like they are moving together. There is no relative motion between them. And in that case, if at all friction would act, it would be static, or it may not act also. That's possible. So when there is relative motion, friction is definitely kinetic. What is meant by relative motion? Now look here. If you stand on B and observe A, it should be moving. Don't you think so? If you go to B's frame, how to go to B's frame? Whatever is B's velocity, add negative of that to B also and to A also, and to ground, to river, trees, everything you add. So now effectively B's velocity is 0. Why? Because it was 4 and you added negative 4. It was going with 4 to the right and you added a 4 to the left. So the velocity is velocity of B is 0. And in B's frame, how is A moving? A has a velocity 4 to the left and 3 to the right. If you add both of them, it will be 1 to the left. So in B's frame, if I write here, in B's frame, A is moving to left. So the friction on A will be to the right because friction opposes relative motion. And another important concept. Many people sometimes say friction opposes motion. No, friction may help in motion also. I am able to walk because of friction only. And we will see many other examples where friction will help in motion, help in movement. So friction does not oppose motion. Friction opposes relative motion, or it opposes the tendency of relative motion, one of the two. If there is relative motion, friction opposes it, the type of friction will be kinetic. If there is a tendency for relative motion and if friction is acting, then that friction will be static in nature. We'll see that later. So now in B's frame, A is moving to left and hence friction on A is to the right. So whenever two surfaces are moving relative to each other, you go to one of the surfaces and look at how other is moving. If other is moving to the right, friction on the other will be to the left. If other is moving to left, friction on friction on that will be to the right. So in B's frame, A is moving to left, so friction on A will be to the right. So if I show that with a red color here, friction on A here will be to the right. What about reaction of this friction? So you should ask the question, who is exerting friction on A? B. B is exerting friction on A. So reaction of this friction will be on B due to A. So on B friction will be to the left. On B friction will be to the left. Okay, so that is the point here. You could have also done it in a slightly different way. You could go into A's frame Let's do that. You can go into A's frame. I'm just erasing this. Okay. And then you can look at how B is moving. How to go to A's frame, add negative of A's velocity to himself and to all objects in the universe. Now A is at rest and B is moving to the right. So friction on B will be to the left, as we have seen previously. Friction on B will be to the left. The reaction of this acts on A and it will be to the right. So it's very simple to find the direction of kinetic friction. Not a big deal. Okay. So I know the direction of kinetic friction. Now what about the magnitude of kinetic friction? What is its value? It has a very simple theory. Kinetic friction value is given by a constant called mu, or sometimes written as mu k, is called coefficient of kinetic friction. I'll tell you what it is. Multiplied by the normal contact force between the surfaces. Now, this is something very important. The frictional force acting between two surfaces depends on the normal contact force between the surfaces. Very interesting. Actually, this is an approximate theory, and in all our problems, we will stick to this theory and it gives very good results. The exact theory is very, very complicated for friction. So why should friction depend on the normal contact force? Let's see with an example. Suppose there is a block, a heavy block, okay, and you are luckily pushing it. There is a opposition to your force, which is friction. The block is moving with certain velocity. You are pushing it with some force. Block is moving. So there is relative motion between the block and the floor. So if you stand on the floor, the block is moving to the right. So friction on the block will be to the left, and that friction will be kinetic. Now imagine you are pushing this, the block is moving. Now imagine one fellow comes and sits on top of the block. What will happen? Then to make the block continue to move, you have to apply maybe a greater force. Otherwise, if he is a heavy person, soon the block may come to rest. So what the hell happened when the person sat on the block? What did happen? The person sat on the block, he is pressing the block with certain force, and as a result, the block pushes the ground. The block is resting on the ground or moving on the ground. It pushes the ground with a greater force. So ground will exert a greater normal force on the block now. Okay, now the ground is exerting a greater normal force. And you can immediately feel that when the person sits on the block, friction also has increased. So when this normal force increases, okay, the interlockings between the bottom surface of the block and the ground are kind of now a bit more stronger, and the friction has increased. So you see, the friction between two surfaces depends on contact force between the two surfaces. As per our theory, if this contact force is zero by any chance, then we say friction is also zero. It may be wrong in some cases. I'm not denying that. Okay, I could give a very, very strange example of a block with this kind of teeth and another block with another block with this kind of teeth. So there may not be any contact right now. There are gaps between the upper pink colored block and this pink color is the lower surface of the block. This yellow one is the upper surface of the ground. There is no contact right now. But when you try to move this, there will be obstruction. These teeth will get interlocked, or there may be some horizontal force, right? So there can be friction without normal force. But we are not going into such a complex theory. We want to make it simple. and it works good for all our practical purposes. Okay, the theory that we are discussing right now for friction is good enough in all practical cases. Whenever you want to find out the friction on a moving block or some practical scenario, it works, no big deal. So the kinetic friction depends on the normal force between the two surfaces. The normal force is more, the interlockings are stronger, and friction will be stronger. So the kinetic friction is given by this constant mu k. It's called coefficient of kinetic friction. I'll talk about this, multiplied by the normal contact force. Now, this coefficient of kinetic friction, okay, it's a dimensionless constant. It has no dimensions. It's just some kind of, you can say, proportionality constant. It tells you something about the roughness of the two surfaces in contact. If the two surfaces in contact are very rough, then mu k will have a higher value. Or if they are relatively smooth, mu k has a lesser value. If there is no friction between two surfaces, mu k could be 0. Okay, it's not a very practical case, but in problems sometimes we say frictionless surface to make things simpler and to get a feel for the problem before we go to the more complex case. So in such case, even the coefficient of friction could be given as 0, in which case there won't be any friction between the surfaces in contact, in spite of being having a normal force. Now this mu k, generally mu k value lies between 0 and 1, but there is no rule that it should be less than 1. It can be more than 1 also. It can go to 1.52 and so on. Okay, it can go to those values. Even sometimes even higher values also is possible, depending on the roughness of the two surfaces in contact. Generally, for most surfaces, it lies between 0 and 1, but there is no compulsion that they should be less than 1. It could be greater than 1 also, the coefficient of kinetic friction. Okay, now the other thing, the more the value of this mu k, the more the kinetic friction. More value of mu k means the surfaces in contact are very rough. More will be the friction then. So friction depends on this mu k and n. For example, suppose there is a block of mass 2 kg, somebody is pushing it and it is moving with certain velocity, let us say 2 meters per second. Some velocity, I don't mind whatever is the velocity. It may be 1 meter per second, 2 meter per second, or whatever. And I want to find the friction acting on the block due to the ground, and somebody gave me the coefficient of kinetic friction to be 0.6. It's just a number, there are no dimensions for it. So how to get the kinetic friction? We have a simple direct formula. Kinetic friction is simply mu k into n. So you must get the normal contact force, here between the ground and the block. Okay, any one of them. You can get the normal on the ground by the block, or you can get normal on the block by the ground. It's easy to draw the free body diagram of the block. There is normal on the block. Earth is pulling this block with 20. I'm taking G as 10. And the block cannot go vertically down, right? It wants to go to the center of the earth, but in that process, it is pushing the floor, and floor countered it with appropriate n. So in this case, n will be 20. N will adjust to 20 because n is a deformative force. The more the downward force, the more with the value of n. Suppose if you put another 5 Newton here, then n will go to 25. So it can adjust, the value of n can adjust. So here n is 20. So friction will be mu k n. Mu k is given to be 0.6 into 20. So it will be 12 Newtons. That's the kinetic friction. So kinetic friction is very simple. Its formula is very simple. It is simply mu k into n. Mu k will be given to you. N you can find from the scenario, whatever is given to you. And from that you can get it. For example, if I have a wall like this and a block is being pushed like this with 100 Newton, and the block is also coming down. Its mass is, let us say, 2 kg, and the coefficient of friction between wall and the block is given to be 0.5 kinetic friction. He is asking you find frictional force on block, for example. So it is coming down, let us say, with some 4 meters per second, some velocity. Because of the Earth's pull, it is coming down. So it's like you pressed the block against a side wall and slowly it is coming down. It is also possible to press the block so that it doesn't move down. In that case, static friction will act. Anyway, let's draw the free body diagram of this block. So I have 100 Newton to the left. This should have actually taken the block to the left, but it's not able to move to the left because wall is there. So wall countered it with a normal contact force, which also will be 100 Newton. So because the block does not move horizontally, N will be 100 Newtons. So what will be the kinetic friction? Mu k into N. Mu k is given to be 0.5. N is 100. Okay. So it will be 50 Newtons. So there is a kinetic friction of 50 Newton acting. What about the weight? Weight is only 20 Newton. Now you might be thinking, sir, how come upward force is 50 and weight is 20 and the block is moving down? It could have been given some velocity initially, but it will slow down. Why it will slow down? Because the net force in vertical direction is up. 50 minus 20 or 30, it is up. While the block is moving down, the acceleration is up, so it will slow down. Eventually, one day it might stop. That's a different issue. As of now, block is going down with 4. So there is relative motion between the block and the wall. So there is kinetic friction. Its value is mu kn, which turns out to be 50 Newton. So here friction is the retarding force. It's slowing down the block. Gravity is trying to accelerate it, but friction is retarding. Okay. So the retarding force. So the net force in the vertical direction will be 30 up. So acceleration will be 30 by 2 or 15 meter per second square. So after what time the block will stop? Initial velocity 4, final 0, acceleration is minus 15. You can find the time by applying the all famous V equal to U plus AT and get the answer. Okay, this is as far as kinetic friction is concerned. So kinetic friction is simple. It's got a simple formula mu k into n. Mu k will be given to you. It tells you how rough the two surfaces are in contact. If mu k value is high, then both the surfaces which are in contact are extremely rough. Okay, if mu k value is low, the surfaces in contact are less rough, there will be lesser friction. And the friction depends on normal contact force compulsorily. Now, so kinetic friction, I have nothing more to say here. Let's go to the more complicated static friction. This is a nightmare. This is very complex. It's not simple. So when is static friction coming into picture? When the two surfaces in contact are not moving relative to each other. They are not moving relative to each other. They are relatively at rest, but there is a tendency. Somebody is trying to move them apart, and this static friction is resisting that tendency. It's like, I have a heavy block. You're trying to push it, it's not moving. Why it's not moving? When you try to push it, the block wants to move with respect to the floor, but friction says, hey, come on, and it will act. So this friction, which is acting, will be the static friction. Why is this coming into picture? Now, if you look at the lower surface of the block and upper surface of the ground in a microscope, the lower surface of the block may look like this, and the upper surface of the floor, which is in contact with the block, may look like this. So when you see with a naked eye, you feel that the block is perfectly in contact with the ground. But if you see in a microscope, there are gaps. You see these gaps are there. So the lower surface of the block and upper surface of the floor are not in perfect contact. There are gaps. There are points where the molecular bonds are formed. For example, here, wherever they are touching there is some bond formation. The ground molecules and the block molecules formed a bond. This bond formation is called cold welding. Okay, without you doing any heating or anything, bonds have been formed and there is a welding. Both the surfaces got glued to each other. That's the reason when you try to apply a force, it doesn't move the block because the block is kind of glued to the floor by these bonds. In order to move the block, you should break the bonds. Now, the thing is this bond breaking force, wherever the bonds break, that force we call it as limiting friction. That limiting value, that means when the bond is ready to break, the force exerted by these bonds, okay, that's called limiting friction. That has got a formula mu sn. Again, it depends on normal force, and just like mu k, mu s is the coefficient of static friction between the two surfaces in contact. Sometimes both in problems we take both mu s and mu k to be same, but in general mu s is slightly higher than mu k. In general, mu s will be more than mu k. That is the practical scenario. Okay, it is what is found practically. So when the bond is ready to break, just ready to break, at that moment, whatever force it exerts on the block, whatever friction is acting on the block, that's called limiting friction. That's got a formula mu s n. But if the bond is not ready to break, then the friction that acts between the block and the floor, that is called static friction. It has no formula. So let me explain this in more detail. Suppose, look at this. I have a block of mass 2 kg. Let me say the coefficient of static friction here is 0.5 and I'll take G as 10 meter per second square. So let's first find the force exerted by the bonds which are formed here due to cold welding when the block is ready to move, when the bond is ready to break. What is the friction? So we call it as limiting friction, or it's also called maximum value of static friction. The friction that is acting here is called static friction because there is no relative motion. So the limiting friction or maximum value of static friction, that's got a formula mu kn, that is mu sn, that is 0.5 into n, in this case is again 20, right? So it is 10 newtons. So unless you apply 10 newton, the bonds won't break. Now suppose you are applying only 1 newton, the bonds will laugh at you. You poor fellow cannot break me. It will also counter with 1 newton. So you applied 1 newton force, the friction is also 1 newton. Suppose you increased this to 2 newton, friction also increased to 2 newton. Bond is not yet broken, bond will break at 10 newton. Friction is still laughing at us and saying, you fool, you cannot move us. So you see the friction is adjusting its value. That's the problem with static friction. It's a self-adjustable force. Kinetic friction cannot adjust. It's got a fixed value mu kn. There ends the matter. Kinetic friction mu kn over. It has got only one value. Static fellow, depending on what force you are applying, is increasing the strength. You apply 3 newton, static friction is 3 newton. So this way you increase till 10 newton. Static friction also reaches its maximum capacity of 10 newton. Now, if you apply anything more than 10, the bonds will break. Now, friction is afraid of you. You already reached 10 newton. Friction says, oh my god, this fellow is way powerful than me. And the moment you apply 10.01 newton, let us say, the bonds are broken, the block starts moving. Once it starts moving, the type of friction will be kinetic. So now the problem is the static friction value has been changing. Many people wrongly say static friction value is mu sn. No, that is the maximum value of static friction. So mu sn will give you the bond breaking force between the two surfaces in contact. But what is the exact value of friction? That depends on your applied force. You applied 1 Newton, block is not moving, so friction is 1 Newton. You applied 2 Newton, block is not moving, so friction is 2 Newton. So the concept is this: how to calculate value of static friction. Now this is the point: how to calculate the value of static friction, not only here but in many more complicated cases. The answer is straightforward. There is no formula for static friction. Use Newton's laws. This is the concept. You have to use Newton's law, Newton's second law, to calculate the value of static friction. It might appear right now as a very strange statement, but no, this is the very powerful concept. For example, here, suppose I applied 1 Newton, block is not moving. What is the value of friction? Take it as F. Block is not moving, so apply Newton's laws. Suppose it is 2 kg block. Net force 1 minus F is mass into acceleration 0. It's not moving, so F is 1. You see, I applied Newton's law and I got F as 1. Suppose I increased this force to 2. Block is still not moving. Apply Newton's laws. 2 minus F is 2 into 0. Again, we'll get F as 2. So you are getting the friction value, static friction value, by applying Newton's second law. Here it looks very simple. We will soon go into cases where there will be block on block and block on block on block, and these two may be moving together. Then how to get the static friction here? Well, you have to apply Newton's laws. That's what I am aiming at in the long run. Complex questions and situations. So static friction has no formula. It has to be calculated using Newton's laws. But hold on. The maximum value of static friction, the limiting friction where bonds break, that's got a formula. That is mu Sn. That tells you where the bonds will break. Like in our previous example, I gave mu S as 0.5. Bonds break at 10 Newton, beyond 10 Newton. So as long as you apply anything less than 10, friction will adjust. You apply 1 Newton, friction is 1. You apply 2 Newton, friction is 2. You apply 3 Newton, friction is 3. You apply 4 Newton, friction is 4. You apply 10 Newton, friction is 10. It is worried. It is worried right now. Oh my God, this fellow has reached my limiting value. You apply slightly, any force slightly more than 10, the bonds break, the block starts moving. And once it starts moving, it is no more the forte of static friction. It is the forte of kinetic friction, whose value is mu Kn, right? So this is the whole idea. So what is the concept if I put it? My static friction will lie between 0 and the maximum value mu Sn. This is the concept. The concept is the inequality here, not equality. That is the problem with static friction. The concept of static friction is an inequality. Static friction always lies between 0 and its maximum value called limiting friction. This fellow is the maximum value of static friction, also called limiting friction. Maximum value of static friction, also called limiting. Now, before I go any further, I want to ask you one question. Think about it and tell me. When I am walking on a rough surface, obviously I cannot walk on a smooth surface. My leg may move, but I won't be able to move. So when I'm walking on a rough surface, is it static friction or kinetic friction that is acting on me? Point number one. And what is the direction of the frictional force on my foot? So let's say I am walking. Okay, point number one. Is it static or kinetic friction between me and floor? Point number one. Second, direction of friction on my foot. On my foot. Can you tell me these two bits?
Sir, could you repeat the second question?
Second question is direction of friction on my foot. When I am walking, friction is acting on me. in which direction is it acting? Suppose if I am walking to the right, the friction on my foot, is it to the left or is it to the right, or it doesn't act, or what is the idea?
Sir, the friction will be to the left.
Okay. And the type of friction?
Uh, I think it's static friction.
Okay. You are right in one case and wrong in one case. Can you tell me in which case you are right and in which case you are wrong?
Case 1,
Case one, you are right or wrong?
right.
You are right. Yes. So let me first give you the complete picture. When you are walking, suppose one foot is, I am unable to draw a proper diagram, but let me try. One foot is on the ground, okay, and you have bent forward, and other foot is in the air maybe. And you are trying to walk, right? Now look at this. The foot which is on the ground, this is in the air. So forget it. The one which is on the ground, that and the floor, they are in contact, and there is no relative motion between them. So technically the friction that acts here will be static. If there was a kinetic friction here, your foot would slip on the ground and that is a disaster. That will lead to breakage of bone. Okay, that is dangerous. So the friction that acts on your foot is static, not kinetic. So many people think that, oh, I am moving, sir. The floor is on the rest with respect to floor. I am moving. Okay, you are moving, but the foot which is actually in contact with the floor is not moving. You must take the two surfaces which are in contact. Your body is moving, but the lower surface of the shoe which is in contact with the floor is not moving. You have to see those two surfaces which are in contact. Is there a relative motion between them or not? There is no relative motion. There is only a tendency of relative motion. Hence, the friction is static. That's correct. Now, think for a minute. When you're walking with this foot, you are pushing the ground backward and you are taking that support and your whole body is moving forward. So you are pushing the ground back. You are pushing. Look at this statement. You are pushing the ground back. So the friction on the ground is back. The ground pushes you, your foot, in the forward direction, the static friction. And in fact, this force acting on you is what is accelerating you. When I say accelerating you, we shall see later, it is accelerating your center of mass. At a later stage, I'll tell you what will net force do. Net force will cause acceleration of a certain point in our body called center of mass, which we will see later. But you are able to go forward because there is a force on you in the forward direction. If you were having a force in the backward direction, how would you move forward? You are at rest and force acts on you in the backward direction, let us say. How can you move forward? That's not possible. If you want to move forward, you should have, I push you, for example, in the forward direction, you go forward, simple. I pull you back, you come back. Similarly, friction is pushing you forward, you go forward. So friction acts on your foot in the forward direction. And on the ground, friction acts on the back in the backward direction. This is when you are going forward. Okay. So when you are moving forward, friction on you is in the forward direction. Hence you are able to move. This is the force which is making you move, in fact. It's causing an acceleration. You are at rest and then you started picking up speed. So you are accelerating in the forward direction. That's because of friction. That's because of friction. Okay. So I think this is clear. So the kind of friction that acts on your foot is static. It's not kinetic. Many people think that, sir, I am moving, so it should be kinetic. No, you are moving, but your movement is not important. The two surfaces which are in contact, the shoe and the ground, those two surfaces are what you should look at. And there is no relative motion between them. And hence the friction is static. Okay. And it is in forward direction. Obviously, if you are in space, hanging, You can't walk forward. You might move your legs. You might be just swinging your legs there itself like this. You won't go forward. Because there is no support. You are unable to push something back. So if you want to do spacewalk, it's not easy. Maybe you should have some marbles with you or a laser with you. You take a marble and throw it back. Then you start going forward. You continue to go forward now. Again, if you want to stop now, that's another problem. Hey, stop, stop. You can't stop like that. So if you are going forward and you want to reduce your speed and stop yourself, you should now throw a stone forward so that there will be a backward thrust on you and you slow down or stop. So spacewalk is not easy. Very dangerous, very tricky. And you tie yourself to the, some spacecraft. And sometimes, a small velocity by any chance that is given to spacecraft, it will start moving in that direction. So all these are very complex. Now, let me go ahead and solve some problems on static and kinetic friction. But before that, I will set the tempo with an example so that you clearly understand what's happening here. I'll set the tempo with one example. So I will give you 8 cases here. There are totally 8 cases here. Okay, you take mass of the block to be 2 kg in all the cases. You take g to be 10 meter per second square in all the cases. You take mu s as 0.5 in all the cases. You take mu k as 0.4 in all the cases. Generally, mu s, the coefficient of static friction, will be slightly higher than the coefficient of kinetic friction. Just as a recap, I'm telling you kinetic friction has got a straightforward simple formula mu kn. Static friction is a nightmare. There is no formula, but I can tell you it lies between 0 and its maximum value. The maximum value is given by mu sn. So static friction lies between its 0 and maximum value. If it doesn't lie, it cannot be static friction. Okay. The value of static friction, you have to calculate it by applying Newton's second law. Now, I have 4 cases here. In these cases, the block was initially at rest. In these cases, block initially at rest. Okay, it's a 2 kg block. And in the first case, you are applying 2 Newton force. Second case, you are applying 8 Newton force. Third case, you are applying 10 Newton force. And fourth case, you are applying 12 Newton force. So, this is case 1, case 2, case 3, and case 4. Then I have another 4 cases here in the bottom where the same 2 kg block, same 2 Newton, same 8 Newton, same 10 Newton, same 12 Newton. Okay, I call this case 5, case 6, case 7, sorry, and case 8. And in these cases, block is already moving with certain velocity of, let's say, 4 meters per second. Block already moving with 4 meter per second. Okay. In the top 4 cases, block was at rest. In the bottom 4 cases, the block is already moving. So in all these cases, I have to find 2 things. A, friction on block in each case. What is the friction on block? And acceleration of the block in each case. Okay, can you do this? Can you do this? I want you to find friction on the block in each case and the acceleration of the block in each case. Let me ask you one question. In the bottom four cases, when the block is already moving, what is the type of friction that acts? The block is already moving, right? So it has to be kinetic. So bottom four cases is an easier case. 5, 6, 7, 8. The kind of friction is kinetic and it's got its straightforward direct formula mu k n. Mu k is zero point 0.4 and n in each of these cases, because the block is not accelerating vertically, happens to be equal to mg. N may not always be mg. Luckily in these cases n is mg, which is 20. So 8 Newton. So in each of these cases where the block is already moving, the friction is 8. That's straightforward. Whenever there is a relative motion between the lower surface of the block and the ground, or between the two surfaces which are in contact, it's going to be kinetic friction, mu k n direct. Some people ask me here, sir, how come this is a 2 Newton force but friction is 8 Newton? Let it be. The block was already moving. Somebody pushed it or they gave some velocity and also applying 2 Newton force. So right now the forward force is lesser than the backward force. So the block is retarding actually. It will slow down. Its velocity is 4. Eventually it will become 3, 2, 1 and one day 0. After it becomes 0, static friction will take over and maybe the block will not move any further. That's not our concern. What about this case, case 6? 8 Newton, 8 Newton, net force is 0. Now we should go to Newton's first law. When net force is 0, the body will do whatever it is doing, and it was moving with 4. So it continues to go with 4 meters per second. So this is a very classic case of where the block continues with 4 meters per second forever. This is the case where it will retard. The other two cases, the net force is to the right. Here the net force is 10 minus 8 or 2 Newton to the right. So the block accelerates. Its speed is going to increase from 4, 5, 6, 7, 8 and forever. At least, till relativistic effects will take over, which we are not interested in. And in this case also. So in these two cases, the block will accelerate and speed is going to increase. So in the first case, the acceleration is 8 minus 2, that is 6 Newton force is backward and mass is 2. So 3 meter per second square acceleration to left. Velocity is to right and acceleration is to left. When velocity and acceleration are opposite, block will retard. This is a case where acceleration is 0, block continues with 4. This is a case where acceleration is 10 minus 8 by 2, net force by mass. So 1 meter per second square acceleration. And this is a case where there is a 2 meter per second square acceleration. So bottom four cases I got the friction and the acceleration matter set. The top four cases. In the top four cases, the block was initially at rest. It was not moving. So will it move or not? For that you should know the limiting friction, the bond breaking force, limiting friction. Let's calculate limiting friction. It's mu Sn, mu S is 0.5. It's given here, right? And N is same 20. So 10 Newton is the bond breaking force. So until and unless you apply something more than 10, the block will not move an inch. So here you are applying 2. Friction will laugh and say, ha, 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 you cannot break me. I'll adjust myself to 2 and acceleration is 0. So static friction is self-adjusting. It can adjust its value, right? Even direction it can adjust. I am pushing with 2, it is opposing me with 2. Suppose suddenly I change this side and apply 2, then friction will also reverse its direction and oppose me. It's opposing. Then second case, I applied 8. Friction again laughs and says, you can't break me. You need at least 10 Newton to break me, or slightly more than 10. So friction applies 8 Newton. Again acceleration is 0. You apply 10. Friction reached its maximum value 10. It's now worried. Right now acceleration is 0, but it's worried. Hey, if this fellow increases the 10 Newton to slightly anything more than 10, I am gone. I am dead. That's what friction is thinking. You apply 12, the bonds have broken already. Because beyond 10 Newton, bonds break. That means the block already started moving. Now the kind of friction that acts here would be kinetic which is 8 Newton, and acceleration. So it becomes the bottom case actually, eighth case. So acceleration is 2 meter per second square. Okay, this problem is very important. In the bottom four cases, already the block was moving, so there is already relative motion, hence friction was kinetic. In the top case, you have to do some analysis, find the bond breaking force, and then check whether your applied force is more than bond breaking force, that is limiting friction, and based on that, you do the problem. Now, I will give you two problems. Both are homework questions. Both are a bit tricky. I've got a wall here, and I've got a block. Its mass is 2 kg. I am applying 100 Newton force like this on the block. So I'm pressing it against the wall. And the coefficient of static friction between wall and block is 0.5. Kinetic friction is 0.4. And the 2 kg block initially at rest. The 2 kg block is initially at rest. Question is, find A, friction acting on 2 kg, acting on 2 kg, and part B, acceleration of 2 kg. This is one homework question. Now the second question is very notorious. So let's look at that. I've got an inclined plane, the angle of inclination 30 degrees. I've got a 2 kg block here. The coefficient of static friction is 0.5, kinetic friction is 0.4. Now, what force F should I apply on the block so that it doesn't slide down? What force F is to be applied on block so that it does not slide down? Now, without applying force, will it slide down? Let's check it. Suppose you don't apply any force. I am giving you four options, by the way. 10 minus 5 root 3 Newton, 10 Newton, 10 plus 5 root 3 Newton, and 11 Newton. These are the options. But let me do give you some small idea about this problem. If you don't apply any force, and you draw the free body diagram, right? You have got normal contact force, you have got mg cos theta, 20, I'm taking g as 10. So 20 into cos 30 is root 3 by 2, that is 10 root 3. mg sin theta, that is 10. Now, what is the bond breaking force here? Bond breaking force, mu Sn, mu S is 0.5, N is 10 root 3. N is 10 root 3 because there is no acceleration perpendicular to incline. So mu Sn, N is 10 root 3. First, let me write this. And limiting friction, limiting is mu Sn, 0.5 into 10 root 3 is 5 root 3. So to break bonds between the block and the incline, you need 5 root 3 newtons. How much is gravity applying? More than 5 root 3. So bonds will break and it will go down. So to not make it go down, to make it stay there only, I got to apply some force. Otherwise, this block will slide down, right? What is the force I have to apply? And I have given you four options. You have to select the force from this. This is a notorious question. Think deeply about this. That's your homework question. So these two are the homework questions which we will discuss in our next class. You attempt them. So any doubts in this?